Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. In this particular lecture video, we are starting with the subtopic of representation of data, that is cumulative frequency distribution, CFD, cumulative frequency distribution. Now, what exactly is CFD? So let's get started with the basic idea. That is, let's draw up a table. And let me fill in some values in this particular table. Okay, that always happens at the beginning. Whenever I'm out to draw a table, this happens. And let me just copy this thing and let me paste it over here. And let me change the color. So now, first of all, on the left-hand side, what I have is frequency distribution. And just to be on the safe side, is my voice audible and the screen is all good, all clear? So one or two of you can acknowledge that, especially the one who are in the admins of the WhatsApp group. And over here, I have cumulative frequency distribution. So yes, the speaker is on. So now, what are we doing? We are forming a table. Let's say I'm talking about time in minutes that pupils of a certain class take to reach to school. So this is time. Let's say 10 to 19 minutes, 20 to 29 minutes, 30 to 39, 40 to 49, and maybe one more. Let me just increase the size. That is, let me add 50 to 59. So these are the time intervals that students of a particular class are taking to reach school. And let me fill up with some frequencies. Let's say, let me write 5 over here. Let me write 8 over here. Let me write 11 over here, then 7 over here, then 4 over here. That means there are 5 students who belong to this interval, 10 and 19 minutes. This is the amount of time that they have taken for those people to reach to school. 8 people belong in this category, 11 belong in this category, and so on. Now, the very first thing is that this is class interval. So let me change into class boundaries. So this is 9.5 to 19.5, 19.5 to 29.5, 29.5 to 39.5, 39.5 to 49.5, and 49.5 to 59.5. So that is the first thing that I've done. And let me write over here upper class boundary. And I'm writing over here the upper class boundary belonging to each class. So over here, let's start with 19.5. Then the next one, 29.5. The next one, 39.5. And then 49.5. And then 59.5. And over here, I'm writing cumulative frequency. The word accumulate, that is of the same thing as cumulative. It's another way of writing it. That is cumulative frequency. Now, how many students reach school in less than? Remember this keyword, less than. Less than 19.5 minutes. So I would say there are 5 people who are reaching school in less than 5 minutes. Pretty basic. If I move to the next one, that is 29.5, how many students are reaching school in less than 29.5 minutes? So these are the 8 people belonging in this category as well as 5. So basically you add the previous one also. So that is 8 plus 5, that comes out to be 30. How many people are reaching school in less than 39.5 minutes? That is 11 plus 8 plus 5. So that is 11 plus 8 plus 5, which is already 13 over here. So this comes out to be 24. How many people are reaching school in less than 49.5 minutes? So that is 7 plus this, plus this, plus this. So that is 7 plus 11 plus 8 plus 5, which is what? Which is 24. So 7 plus 24 is 31. And last but not the least, 59.5. How many students are reaching school in less than 59.5 minutes? That is 4 plus all of these. So that is 4 plus all of these is 31. That comes out to be 35. And let me add one more thing. That is 5 plus 8 is 13. 13 plus 11 is 24. 24 plus 7 is 31. 31 plus 4 is 35. Sigma F is 35. This last value should correspond to sigma F. That is the sum of all the frequencies, the students in that particular class. So these are the students of a particular class, and a survey was carried out. And what is the objective of that survey? To take the data, the time to reach school. And what else was there? We drew class intervals. And out of class intervals, we created class boundaries. And then out of class boundaries, we focused on upper class boundary. We focused on the concept of less than, and then we accumulated. We added up the frequencies. So that is known as cumulative frequency. So that is how a cumulative frequency table is created. So now this is the basic thing that we get started with. So we had frequency distribution, class intervals, so class boundaries were given. We have to convert it into upper class boundary. I mean, first the boundaries, and then we will choose the upper class boundary. And then that's how the working is done. That's right over here. We keep on adding the frequencies such that the very last one will correspond to what? It will correspond to the sum of frequencies. Now, let's add one more thing. That is the lower class boundary of the very first class. So lower class boundary of the very first class interval or class boundary. So we are focusing on that. Now, in this case, that is 9.5. So let me write 9.5 over here. Is there any student among these who is reaching school in less than 9.5 minutes? So according to the data, there is none. So now the cumulative frequency corresponding to this is 0. And this is very necessary to write. So now we have all the data. And if I draw up a table, and let me just highlight this thing a little bit more clearly after all the working is done. And this always gives me trouble. That is the blue one. And let me just copy it. And that is how the table will be given. And let me just change the color to blue. So red is for frequency distribution. So we have class intervals or class boundaries. We have the corresponding frequencies. There were 5 of them. 9.5, I'm writing the boundaries. 9.5 till 19.5. 19.5 till 29.5. 29.5 till 39.5. 39.5 till 49.5. 49.5 till 59.5. And the corresponding frequencies were 5, 8, 11, 7, and 4. That is 5, 8, 11, 7, and 4. And then we have the upper class boundary of each, and then we have cumulative frequency. So this is 19.5. This is 29.5. This is 39.5. This is 49.5. This is 59.5. And this value was 5. And then we add 5 and 8, which is 13. 13 plus 11, which is 24. 24 plus 7, that is 31. 31 plus 4, that is 35. And one last thing, this 9.5 will go over here. and the corresponding cumulative frequency is 0. So I'm just writing on the WhatsApp that we have started with the basic idea of forming a CFD, cumulative frequency distribution, its table, its concept, and that's all about it. That's I have taught till the moment. So just acknowledge it on the group. I have written in the first group and the second group. Okay, so this is all good, all clear. The basic idea of CFD. Now keep in mind that it could also happen that the examiner might erase one of these values, or maybe erase one of these values, and just based upon this basic number pattern, you have to evaluate it. We will discuss it when we will be solving a particular question. Now, let me use a diagram, and based upon a diagram, I think this diagram would be perfect. So now let's say I have this data. This is the cumulative frequency, and this is the length in centimeters of some data. So now if I just use this table and let me put some dots over here. So corresponding to 1 is this particular dot, corresponding to 2 is this particular dot, corresponding to 3. So let's go all the way up here. That is somewhere over here. Corresponding to 4, this is the one. And the last one that's corresponding to 5 is this. So let's use this table up and let's jot down the results. So first of all, let me draw up whatever is over here. And let me write over here that is the upper class boundary and the cumulative frequency. So when the upper class boundary is 1, the cumulative frequency is 0. When the upper class boundary is 2, this value is how much? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 small squares on the vertical axis. So when we talk about vertical squares, 10 small squares makes up 40. Therefore, 1 small square is equivalent to 4. So therefore, this is, I think, 1, 2, 3, 4, 5, and 6. So this is 24. So this value over here is 24. And then we have the upper class boundary of 3, upper class boundary of 4, upper class boundary of 5. So at 3, what do we have? So just double check at 3, that is how we are going. We are reading this value, and this value is 80. So this thing over here is 80, and that goes over here. Now let's look at 4. At 4, it's going up like this, like this, like this. It's touching, and then we are reading of this value. This is 2 small squares above 160. So therefore, this is 168. So this is 168 over here. And last one, the 5 one, that is very obvious. That is this 200 over here. So that is 200 over here. So that is the cumulative frequency. Now, what exactly am I working on? So now I'm working on creating. Okay, that is the vendor on the street. So bear with him. So now I have this thing, which is the class boundaries and the regular frequencies. So let him speak first. Okay. Okay, he's talking too much. So now we have between 0 and 1. We have between 1 and 2, 2 and 3, 3 and 4, 4 and 5. And over here, since we are converting from cumulative frequency distribution to frequency distribution, we have to do some subtraction. So basically, whatever the values were, these two were adding up to 24. And then these two were adding up to 80. So now we have to do subtraction in this order. So let's go this way. Between 200 and 168, that is between 4 and 5, what is the difference? That is 32. Between 168 and 80, what is the difference? That is 88. Between 80 and 24, what is the difference? That is 56. And between 24 and 0, what is the difference? That is 24. That means I don't need the data. The data for this part was not given because this is touching 0. So this is lower class boundary of the very first class interval or class boundaries. So there would be nothing below that. If we were talking about 0, it would have touched at 0. It's not touching. So this is a useless thing. So between 1 and 2, there are 24. 24 plus 56 is 80. 80 plus 88 is 168. 168 plus 32 is giving me 200. So that's how this thing is done. So now the next thing that we learned was that the conversion CFT to FT. So this conversion that we just saw, so just have a good look at it and just acknowledge it on the WhatsApp. This is AS1, this is AS2. So just acknowledge on that. Okay. Now there are some other things that we need to calculate. And then I'll give you some time after the basics are done that jot down the things in your register, take around 10 minutes as we do in class, and then we will continue with the journey. So now this is all good, all clear. So we talked about this thing. Now, let me do one thing. Let me pick this thing up and let me paste it over here. And let me calculate some other things that we usually work with. So now over here, I'm interested in 3 things. And those 3 things are what? So let me just draw up a table over here, a circle over here. I'm interested in LQ, which is lower quartile. I'm interested in median, that is the middle value. And I'm interested in UQ, that is upper quartile. Now, when we talk about lower quartile, 25% of the distribution lies below lower quartile. That is the rule. When we talk about upper quartile, 75% of the distribution lies below upper quartile. And when we talk about median, it's the middle value. 50% of the distribution lies below the median. Sometimes I'll be using the symbol Q1 for lower quartile, Q2 for median, Q3 for upper quartile. Now, if I work with these 3 basic things, let me use this table to calculate it. So now the working is for lower quartile, for median, for upper quartile. For lower quartile, 1/4 of cumulative frequency, and you read the corresponding value on the horizontal axis. So we start with the vertical axis. So VA stands for the vertical axis. And what will always be there on the vertical axis? That is the cumulative frequency. And what will be on the horizontal axis? HA, that is horizontal axis. That will always be some kind of class boundaries. It could be marks, it could be length, it could be weight, and so on. So it could be marks, it could be mass, it could be length, it could be time, and so on. And we will read that. So now the rule is we start with the vertical axis and go towards the horizontal axis. So that is the first thing that I'm working on. And let me also copy this thing because I'll be needing this table a bit more. So let me just paste it over here. And for some other things, I'll be using this thing also. So now 1/4 of cumulative frequency. So when we talk about 1/4 of cumulative frequency, so that is 1/4 of 200. That comes out to be 50. And we are calculating median and this thing, and just looking at the colors that I've used, that is half, that is 50% of 200, that is 100. And then we are using 3/4 of 200, that is 150. So basically, we will use this 50 on the vertical axis and read on the horizontal axis. So let's start with 50. So we have, this is 40, and let me mark it down. So this is 40. Over here, let me double check. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All good. This is 40. So now over here, 50 is here. And let me choose a thin marker. Touch the graph. Read off the value. And this is the first thing that I'm getting. That is 2.1, 2.2, 2.3, 2.4, 2.5, 2.6. So that is horizontal axis. One small square is 0.1. So that is 2.6. So therefore, this value of lower quartile is 2.6 centimeters. All good, all clear? So now let's use the vertical axis, read off the horizontal axis, and we will get the upper quartile. So 100. So there is 80 over here. There is 120 over here, double check. 84, 86, 88, 92 actually. 84, 88, 92, 96, and this is 100. So now let me choose a purple color marker. Let's go to 100, touch the graph, and then read off the value. And this value is coming out to be what? This is 3.1, 3.2. So this is 3.2. So the upper quartile is coming out to be 3.2 centimeters. All good, all clear. Let me double check. This is 3.1. No, not this thing. This is 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9, and 4. Yes, it's all good. So now 3.2 is this thing. Now the last one, that is the green one. Now we are going on the vertical axis. We have to read the horizontal axis, and this will be upper quartile. My bad. Let me correct myself. This is the median that I just calculated. So this one was the median, which is 3.2, and upper quartile. So 150, let me choose a green marker. So 150 is where? So this is 160. That's right over here. That's the green marker. That's 160, 156, 152, and over here is 150. So let me go to 150, touch the graph, read off the value, and of course, they take into consideration the human error thing. So this is 4, this is 3.9, 3.8, 3.7. So therefore, upper quartile is 3.7 centimeters. And if we are interested in IQR, which is the interquartile range, and this is also a measure of dispersion, and we will talk about it in detail when we talk about the reasonings. This is interquartile range. This definition is upper quartile minus lower quartile. What is the upper quartile? The upper quartile is 3.7. What is the lower quartile? The lower quartile is 2.6. So what is the difference? The difference comes out to be 1.1 centimeter. That is the value of interquartile range. So all good, all clear. Now I'll explain something more using the same diagram, and then you can take some time, jot it down, and then we will continue. Now, let's say there are two kinds of questions that they can ask. Let me just highlight this. So either they can ask questions from the vertical axis to the horizontal axis, or horizontal axis to the vertical axis. Vertical axis is cumulative frequency distribution to upper class boundaries, or upper class boundary to cumulative frequency distribution or just cumulative frequency. So let me just erase this thing. Now let's say, how do we get started? Let's start with the blue one. If I say, let's say part A, how many? This is length in centimeter. Let's say it's about a leaf. Or maybe let's say it's an insect. So now the length in centimeters of the insect, how many insects of that particular variety has or have a length lesser than, let's say, 3.5 centimeters. That means we would go to 3.5. And this is 3, 0.1, 0.2, 0.3, 0.4, 0.5. This is 3.5. And now I'll go up like this. I'll touch the graph. I'll go to the left. And this is part A. I'll read this value. This is A. This is part A. This value is 120, 124, 128, 132. This answer is 132. So therefore, the answer is 132 insects are there, which have a length lesser than, that's the keyword, lesser than 3.5 centimeters. So this is direct reading. Now, let's look at part B. If I say that how many insects have a length greater than 1.9 centimeters. Now it's asking for greater than. So now the focus is on greater than 1.9 centimeter. But it's based upon upper class boundary. So whatever we will get, that is based upon less than. So now, first of all, go to 1.9. So let's go to 1.9. Let's go up, touch the graph, go left, read off this value. So this is for part B, this is for part B, this is 4, 8, 12, 16, 20. So this answer is 20. That means 20 insects have a length lesser than, because it's based upon upper class boundary, lesser than 1.9 centimeter. Therefore, the total minus 20. What is the total? 200 minus 20, which is 180. They have a length greater than 1.9 centimeter. So greater than 1.9 centimeter. Is this all got all clear? The part A and the part B. Part A, part B, insects. And we are talking about horizontal to vertical. Horizontal to vertical. So I'm just waiting for the reply for this. This is AS2. This is AS1. Okay. Okay. All good, all clear. Now, let's use the same diagram, but on a different page. So first of all, let me just copy this. And let me move to the next page. Now, I'm focusing on this, the same diagram, so that it does not get all messy up here. Okay, now we'll be moving from the vertical axis to the horizontal axis. So now part C, from the vertical axis to the horizontal axis. So part C and part D. Now let's say 80 insects have a length lesser than L centimeters. Find L. Now, red marker. Let's go to 80. Touch the graph. Go down. This is part C. This is part C. This value is 3. So therefore, L comes out to be 3 centimeter. And this is direct reading. Why is it direct? Because it's based upon the concept of less than. Just focus over here also. When it is lesser than, that is direct. If it's greater, it's indirect. Okay, so we calculated the lesser one and then subtracted it from the total. So indirect means subtraction from total cumulative frequency. So now coming back to this was direct, part C. Let's move to part D. Let's say, let me choose a number 140. 140 insects, or let me choose the word 60 for a second. So 60 insects have a length greater than, let's choose the word K centimeter. Find K. Now the trick over here is that it's written greater. 60 insects have a length greater. The total insects that we have the data for, that is 200. That means 60 are having a length greater. We have to convert it into lesser. That means 200 minus 60, which is 140. They have a length lesser than K centimeters. So that indirect thing is also there. So again, this thing is there and it's indirect. So convert the statement to lesser. Convert to lesser. Over here, you can do the addition, subtraction on the vertical axis with the number of insects. But we cannot do the addition, subtraction for the length. How can we take one insect length and add it to the other? We cannot. So now we have to go till 140. So now this is 120, 1, 2, 3, 4, 5. This is 140. So now let me go to 140. Touch the graph. Read of the value and this value. Let me first label it. So this is part D. This is 140. This goes like this. This is 3, 3.1, 3.2, 3.3, 3.4, 3.5, 3.6. This is between 3.5 and 3.6. So let me write this value as 3.55 centimeters. All good, all clear? So just have a good recap of it. There were questions in which we worked from horizontal axis to the vertical axis. And there were questions in which we worked from vertical axis to horizontal axis. Lesser is direct reading. Indirect, you have to do subtraction from the total and then work it out. So let's take a small break over here, a break for me, but work for you. So take around like 10 minutes. Copy everything down because the questions that we will do for practice, they're all based upon this. So let me first pause the recording over here and let me pause the recording. So now let's do some past paper questions. And over here, let me just do a small correction. This is representation of data. The exercise starts from page 231. It's about frequency distribution, cumulative frequency distribution, the mean and the variance and the standard deviation thing, the coding, and everything in it. So now let's look at this question. And I think I forgot to just do the correction over here. No, I think I used it in that particular thing for the previous example. From here, the question starts. It says, Annabelle measured the lengths in centimeters of 200 caterpillars. So this was the insect question. Now this is with wordings. Her results are illustrated in the CF graph below. So when we draw a CF graph, we mark these points and we join it smooth hand. So there are two kinds of CF graph. When we talk about CF graph, we have seen that there are the vertical axis always has the cumulative frequency in it, and the horizontal axis has what? The class boundaries in it. Now, one of the cumulative frequency graph is called cumulative frequency curve. That is a smooth curve that we draw. This is also known as ogive. So that curve like this with the points over here, and then when you join them, that's ogive. Also, the other option is we join the points with short line segments like this. And then there is another point over here, let's say over here, and we join it like this. Another point, we join it like that. So this is a cumulative frequency polygon. So this is CF polygon that we form. And the accuracy level is different. All we have to do is to follow the instructions, the examiner's instruction. What exactly do they need? So over here, they simply say cumulative frequency graph, and they have drawn it like this. So it's the same curve that we have seen. Estimate the median and interquartile range of the length, and we have just solved it over here. So before all these parts, we did the lower quartile, the median, the upper quartile, and the interquartile range. So it's the same curve that we have solved. And what else are they asking? They are asking us estimate how many caterpillars had a length between 2 and 3.5 centimeters. So if they are asking us how many, so what are they asking? They are asking us the number. So we go to 2, we read of the value, we go to 3, we read of the value, and then let's see what do we do. So we go to 2 and we touch the graph and we go left. So this is from horizontal axis to the vertical axis. And we go till 3.5. So this is 3, this is 1, 2, 3, 4, and 5. So at 3.5, we go up, we touch the graph, and then we go left. So in both cases, we were going left, and this is part 2. This is also part 2. This value over here is 4, 8, 12, 16, 20, 24. This value is 24. Over here, this is 120, 124, 128, 132. This is 132 over here. So when we say part 2, that means 24 insects or caterpillars, they have length lesser than 2 centimeters. And then 132 insects, caterpillars, they have length lesser than 3.5 centimeters. So therefore, in between, what is the answer? So 132 minus 24, which is how much? This is 108 insects or caterpillars. That is the answer. So this is caterpillar. Instead, I'll write insects. That is the answer. So this is for part 2. So part 2 is about horizontal axis to the vertical axis, from the class boundaries to the cumulative frequency and the difference between them. Now, what about this one? Part 3. 6% of the caterpillars were of length L centimeter or more. That means 94% of caterpillars were of length L centimeters or less. So I have retranslated it, just like we did in the chapter that is called normal distribution. So it's a matter of perspective. There is a length L such that more than L is how much? That is 6%. Therefore, less than L is how much? 94%. Now, how many caterpillars are there? 200. So let's first evaluate 94% of 200. That is 90, 90, 180, and 4 is 8. That is 188. So now from the vertical axis, we will go to the horizontal axis. The value on the vertical axis is 188. and just go that way. So this is over here 200. This is 4 less 196. This is 192. Go this way, touch the graph, and then go all the way down like this. So this is a 192. This is part 3. This is part 3 like this. This is going like this way. This is going this way. And this is 4, 4.1, 4.2, 4.3, 4.4, 4.5, 4.6. This is 4.6. So this answer is 4.6 centimeter. That is the value of L. All got all clear with this particular question? That is question number 41. So let me write over here. That's the AS level. That is question 41. And you saw the kind of questions that we did: the median, the lower quartile, interquartile, and the upper quartile and the interquartile range that was dealt with earlier. And over here, we focused on 2 parts. Second part was about this thing. That is the horizontal axis to the vertical axis. And part 3 was what? That is from the vertical axis to the horizontal axis, but I retranslated it. Why? Because it was based on more than, so therefore I converted into less than. So that is all got all clear. Okay, Ji. Now let's look at this question. It says the following histogram represents the lengths of worms in a garden. Calculate the frequencies represented by each of the 4 histogram columns. And there should be, the next one, we have to draw a CF graph. I mean, we won't draw the whole graph. I'll just draw up the table. So now the first thing over here, what is this particular question all about? So this particular question, let me write it. This particular question is all about a histogram. From that, you have to get a frequency distribution. From a frequency distribution, you have to create a cumulative frequency distribution. And then we have to draw a CF graph, which could be a curve, a CF curve, or it could be a polygon. That is your choice. And that's all about it. The next thing that we need to focus on, that there is frequency density on the vertical column. So always focus on the scale. So this is 1, 2, 3, 4, 5. 5 is 2 units. 5 small squares is 2 units. Therefore, 1 small square is 0.4 unit. Keep that in mind. And on the horizontal, we don't have to worry about it that much, because this is like 0 and 5 and 5 and 10 and 10 and 20 and 20 and 25. So that's not an issue. So let me make a class interval or class boundary column. That is 0 till 5, 5 till 10, 10 till 20, and 20 till 25. And then I'll be filling up the frequencies over here. Or let me first write the frequency density. Let me write the class width, and then I'll write the frequency of that particular class. So let me fill it up this way. So between 0 and 5, the height is 2. Between 5 and 10, the height is 8. Okay. Between 10 and 20, the height is 12. 10 and 20, the height is 12. And 20 and 25, the height is what? So that is this thing over here. So this is 1, 2, 3, 4, 5. This is 6. So therefore, they all are good integers. What about the class width? The class width is 5. The class width is 5. The class width is 10. The class width is 5. And which formula are we using? We are using the formula frequency density is class frequency over class width. So this is not cumulative frequency. This is class frequency divided by class width. In other words, frequency density into class width will give me class frequency, which is, remember, area of the bar. So this is, just multiply these two. So 2 into 5, that is 10. 8 into 5, that is 40. 12 into 10, that's 120. 6 into 5, that is 30. And that's how the table is created. So this is a frequency distribution. So keep in mind, this is frequency distribution. What more needs to be done? You have to form a cumulative frequency distribution. So let me make up a table like this. And this is the upper class boundaries. And I need cumulative frequency. So between 0 and 5, let me choose 5. Let me choose 10. It does not make a difference whether it's equal class width or unequal class width. So remember, equal or unequal class width are no issue in creation of CF graph. So now over here, the cumulative frequency, first of all, less than this 5 over here. Let me use a red marker. This 5 is this 5. This 10 is this 10. This 20 is this 20. This 25 is this 25. And less than 5 is 10. So let me write 10 over here. Less than 10 is this 40 plus 10, or let me draw the arrow this way. 10 plus 40 is 50. 50 plus 120, that is 170. 170 plus 30, that is 200. And this was about the total number of worms is 200. All good. We just need one missing piece of the puzzle. The lower class boundary of the very first class interval is 0. And I'll write a 0 over here because according to the data, there is nothing below 0. All good, all clear? So now when you have created, you can join the dots. So 0, 0. Let me just draw the graph over here. So the horizontal axis and the vertical axis. So that is the horizontal axis. That is the vertical axis. Let me label over here cumulative frequency. Let me label over here, that is the following histogram, length of worms. First, we were talking about insects and caterpillars. Now it's length of worms. And I think the unit is centimeters. So if there is any unit, do write it. Yes, it is over here, centimeters. So the first dot is 0, 0, the blue one. So this is 0, 0. And we are talking about 25 centimeters. So let me count the squares. So if I count the squares, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let me make it, if I make it 5, so I think that would be better. So therefore, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that is 5. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That is 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That is 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That is 20. And 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And that is 25, if I'm not mistaken. So this is all good. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All good. So now on the vertical axis, we are going till 200. So I think I'll just play with the dark lines. So over here, this is 1, 2, 3, 4, 5. This is 5. 1, 2, 3, 4, 5. So if I write 50 over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 100. I think this is good enough. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 150. And 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And I have filled more than 75% of the space. So that is all good. So now I have 0, 0. That is the first point. The second point is upper class boundary is 5. Cumulative frequency is 10. Upper class boundary is 5. Cumulative frequency is 10. So that's over here. The third one, that is 10 and 50. That is 10 and 50. That's over here. The third one is 20 and 170. So 20 and 170. So keep on going on 20, 20, 20. That is 150. And keep on going up. So that's 160. That is 170. So let's erase this thing. these two. And the last one is 225. So that is 25 and 200. This way, this way, this way. Okay, so if I'm not mistaken, these are the 5 points over here. And let me join them. So I have this curvature thing over here, like this, like this, like this. So it's not very great, but still it would do the job. Okay, so that's how the curve is made, and that's how the thing is created. And then you can calculate the median, the interquartile range, and all thing. And this is what we have done in mean and standard deviation. Okay, over here, we have the same thing, the same kind of question, nothing special. All we have to do is to convert from frequency distribution to cumulative frequency distribution. The boundaries are already given. Now let's look at this particular question. It says the daily rainfall X millimeters in a certain village is recorded on 250 consecutive days. That's the sum of frequency, and that corresponds to the last value in a cumulative frequency distribution. The results are summarized in the following CF table. So first of all, this one is a cumulative frequency table. And what are they asking? The first thing, on the grid, draw a CF curve to illustrate the data. And for that, this table would be enough. And then the second part, on 100 of the days, the rainfall was K millimeter or more. Use your graph to estimate the value of K. That means on 100 days, the rain was K millimeter or more. Therefore, 250 minus 100, that is 150. On 150 of the days, the rainfall was K millimeter or less. So we are going from the vertical axis and the horizontal axis. So if the curve is like this, just to give you a brief idea. So if the curve is like this, and we are starting from some value, and it's going this way, and we are reading this value. So no, not this thing. I don't need this, something like this. And then what we do is that we go to this value, that is 150 on the CF curve. We will touch the graph, and then we will read this value. This value will be K, provided we convert it into lesser than. So that is the basic stuff. Now the third thing, that is calculate estimates of mean and standard deviation of the daily rainfall. In order to calculate mean, we have the formula X bar sigma fx over sigma f, as we have seen before, and the variance square, that is sigma fx square over sigma f minus X bar square. Now, how is that possible that we obtain these values? That means we need a frequency distribution table for this. So let's create a frequency distribution table out of a cumulative frequency distribution table. So let me just draw a grid so that I can fit in the values. And let me write over here, and even before that, let me just fit it like this. And let me write over here the class boundaries for whatever data that we are talking about, which is the rainfall in millimeters. And over here, I'll have the class frequency. Now we have these values. That is, let's say, 20 till 30, 30 till 40, 40 till 50, 50 till 70, 70 till 100. So now, first of all, let me just fill up the table, 20 till 30, and then 30 till 40, and then 40 till 50, 50 till 70, and the last one is 70 till 100. Now I'm interested in the differences. So now let me grab a calculator, and so that I don't make any mistakes. 52 and 94, this difference is how much? So the difference between 52 and 94, 94 minus 52, this is 42. Let me fill this up. And over here, 142 and 94. this is 48. And 142 and 172, that is obvious, which is 30. 172 and 222, that is 50. 222 and 250, that is 28. So these are the differences that we see: 42, 48, 30, 50, and 28. So now when we talk about it, so between 70 and 100, that is 28. Got it? Between 50 and 70, this difference is 50. Between 40 and 50, this difference is 30. Between 30 and 40, this difference is 48. Between 20 and 30, this difference is 42. Now, let's do one thing. Let's add it up. Does it add up to the total, which is 250? So this is 42 plus 48 plus 30 plus 50 plus 28. It adds up to 198. And what do we have over here? 250. So 250 minus 198 is 52. That is this number over here. So when we have this number over here, write this number over here, 52. And the rainfall, that has to be between 0 and 20. So this thing is something that you need to be very careful about. So now this table is made. We are all set and ready to roll. So now what I'll do is that I'll write x over here. I'll write f over here. I'll write x square. I'll write fx. I'll write fx square. And I'll just show you the steps. So the mid value is needed. 0 and 20, the mid value is 10. 20, 30, that's 25. This is 35. This is 45. This is 60. This is 85. So that is 10, 25, 35. Let me just leave a gap. And then 45, 60, and 85. So I just need some more space. Okay. So that is 60 and 85. And the corresponding frequencies, that is 52, that is 42, that is 48, that is 30, 50, 30, 50, and 28. And then you would square each value. So that is 10 square, 25 square, 35 square, 45 square, 60 square, 85 square. And then you would multiply x into f. You will fill it up over here. You will multiply f into x square. You would fill it up over here. And then you would use the formulas that I wrote someplace. That's right over here, x bar and standard deviation square, and square root of standard deviation square is standard deviation, and you will get the answer. So there are some more questions also, but let's stop our class at this point. So that is cumulative frequency distribution explained in great detail. Stay tuned for more content on Mathematics with Shahab Yaqub.